Okay, Module 20, Matched Pairs T-Test. I'm going to use the exact same data that I did for Module 19. Now, in Module 20, this is how it will be in your final exam. You're going to have different data, but it's going to look just like this. I'm going to ask you to do a two-sample t-test, a matched pairs t-test, and then a sign test. So this is the second of 3 calculations you're going to have to do on your final exam. So you're going to want to look at this module a number of times. Okay, so what I have to do here, instead of getting the mean and standard deviation for matched pairs is when I am comparing item by item. First thing I have to do is build a new data set. And what I do here, and I cheated somewhat, I knew from my previous calculations that the first sample was bigger than the second one, or if that's x and y, x is bigger than y. So what I did is I'm making a new thing. I'm going to take one column, subtract the other one. And I don't care which way I go, but I'll do it the way that gives me the most positives. Okay, so in this case, I'm taking the left column minus the right column, and I'm creating a new column of data. So 137 minus 113 is 24. 105 minus 105 is 0. 133 minus 135 is minus 2, etc. And I go all the way down to the bottom of the thing, and let's see. I get all the way down. The last item is 123 minus 88 gives me 35. Okay, now, what I need to do now is take my calculator and go back and start putting these numbers, the new data I got, the differences. So I go into my calculator and get the mean and standard data. I'm going to enter in 24, enter it into storage, 0, enter it into storage. Don't skip the zeros. That is an item. Okay? And I do minus 2. Now, how do I get minus 2 in there? You're going to have to play with the calculator to see. If it's on Hewlett-Packard, you would go 2 minus, then enter. Okay, using the sigma plus button. If you're on TI, you go 2, go to the plus minus button, and then use the sigma plus thing to enter it in. And so I would go 24 sigma plus, 0 sigma plus, 2 plus minus sigma plus, 7 plus minus sigma plus, 0 sigma plus, etc. Okay? You go down and you enter all of these items into your calculator. So on the last one was 35. Oops, I didn't go far enough down. Let's see. Okay. You get that in there, you should see n equals 25 in the screen. Now, what you want to do is take that and get the mean and standard deviation of that item. Okay? Now, my mean comes up to be 10.00. My standard deviation of this data is going to be nothing like the others. It's 18.58. Now, it's important for your final exam to remember this. Remember from the first problem, you had 117.84 minus 107.84. That was equal to 10. Okay, what did we do? We took the mean of the first column and subtracted the mean of the second column. Now, on the second set of calculations, this one here, we subtracted first, then we took the mean. Those numbers better be the same. In other words, this minus this should be exactly the same as that. If it is not, you screwed up. Okay? And this is worth way, way, way too much. You want to check this, because if you screwed up, you got plenty of time and you finally go back and recalculate it so you don't lose the points. Okay? Now, when we push the standard deviation for this, we're going to get this number, 18.585. Now, when we do the test, I'm going to have to adjust this for the sample. So I'm going to divide this by the square root of how many items I have. So square root of 25. That's going to take me down to doing my test. Okay? If you think of it in terms of, okay, remember 10 was my mean. My standard deviation is 18.585. I'm dividing that by the square root of 25, or 5. Okay, so this goes into that 3.7 or something. 10 divided by 3.7 gives me 2.69. Now, since this is a t-test, I'd have to go to the table and get the table number. Okay, there were 25 items, so I've got a degree of freedom of 24. I go look it up. I did it in the previous module. It is 2.064. If you're not sure how to do it, check the previous module again. Now the question is 2.69, my calculated t, bigger than t star, the table t, 2064? Yes, it is. So in this case now, I'm going to change my conclusion. On this one, down to the second part, I would say they are significantly different. I would reject the null hypothesis, and I would accept the alternate hypothesis that these two values are different. Okay? Let's just run over this again. I subtracted the items first. Then I take the new data, the subtracted items, okay, the results, the differences, and I enter that in the calculator and get the mean and standard deviation. Then I adjust my standard deviation, dividing by the square root of the sample size, and I'm comparing that difference to 0. In other words, if they're identical, it should be 0. They're separated by 10 on average. Is that significant? Well, I divide by my adjusted standard deviation, my standard error. In this case, it's going to be about 3.7, and that gives me a value. I compare that to the table value, which in this case was 2.064. If I'm bigger than 2.064, then I reject the null hypothesis and accept the alternate hypothesis. So, in Module 19, we tested this data. By the two-sample t-test, they were not significantly different. By the matched pairs t-test, they were significantly different. This is why, because your standard deviation is smaller in the second one. It is a more accurate test, and it just shows you that any time that you have to do a t-test, if I can match up the data, I should use the matched pairs t-test if I can justify it. It is a much more accurate test than the two-sample t-test. The two-sample t-test is the generic one. That's comparing one bunch against another bunch. The matched pairs is comparing item by item. So it is far more accurate, and it is the preferable test to use if it can be justified. You have to have a reason for matching up the data. Thank you.